Howdy! Today we are going to be doing an asynchronous case study on vultures. This case study will perfectly align with our section on ecotoxicology or environmental toxicology. And what we're going to learn is we're going to practice applying the scientific method to an environmental problem. So I'm particularly fond of this case study because I wrote it several years ago when I was learning how to teach with case studies. And so I hope you find it engaging and interesting, and we get to learn about a variety of things with some hands-on real-world issues. By the end of this case study, students will be able to apply the scientific method to critically evaluate environmental data, explain the IUCN Red List and the concept of keystone species, interpret dose-response graphs to find an LD50, and extrapolate the significance of a wicked environmental problem, specifically pharmaceuticals in the environment, and how that relates to their individual lives. Now in handout number 1, Mira mentions her Parsi background and the Zoroastrianism tradition of using towers of silence. This is a fascinating cultural practice where vultures act as natural detritivores. While if it's a wonderful example of human culture interacting with nature, I want to clarify something. The religious practice itself is not causing the vultures to disappear. The cultural context is simply how Mira first noticed the problem and Mira's connection to vultures. The actual threat to the vultures is entirely different. It's a systemic issue, and that's what we're going to investigate today. In present-day Zoroastrianism, the Farvahar is said to be a reminder of one's purpose in life, which is to live in such a way that the soul progresses towards the union with the supreme divinity. Although there are a number of interpretations by individual elements of the symbol, all of them predate the 20th century. In the story, Mira wonders if her childhood vultures are on the Red List. But what exactly is the Red List? Maintained by the International Union for Conservation of Nature, or the IUCN, the Red List is the world's most comprehensive inventory of the global conservation status of biological species. What makes the Red List so unique is that it doesn't just cover mammals, amphibians, and reptiles. It also includes fungi and plant species. The Red List characterizes species based on their risk of extinction, ranging from least concern, like the snowy owl or the Manchurian hedgehog, to vulnerable, like the African elephant, all the way up to critically endangered, like the black rhinoceros or pygmy raccoon. But when you look at these species, what sticks out to you? It might be that they're cute, well known from their favorite childhood storybook, or otherwise likely on someone's list of favorite animal. These are what are often called charismatic species because they are popular, highly recognizable animals, and often highlighted by environmental organizations to generate public awareness, secure funding, and drive conservation efforts. When charismatic species serve as a way to boost funding for conservation and protection of the ecosystem to the benefit of all species in that ecosystem, we often refer to these species as umbrella species because they are acting as an umbrella that helps promote protection for all the species that live near them. Who else is on that list, though? That's not so cute and cuddly. In our case, we are exploring old world vultures. 3 species of vultures we are looking at are the oriental white-backed vulture, the Indian vulture, and the slender-billed vulture. All are classified by the Red List as critically endangered. They are on the list because their population dropped 90% in less than 10 years. But what happened? What caused this massive population decline in these birds of prey? And why does it matter? The decline of old world vultures is highly significant because vultures are a keystone species. A keystone species is a species that exerts a great influence on their community composition and structure regardless of their population size. Keystone species get their name from the keystone of an arch. A keystone is the wedge-shaped stone at the top of the arch that holds the structure together without glue or binding materials. Just as the keystone arch holds the whole structure together, a keystone species exerts a strong control in its community that's disproportionate to its population size. Think of the classic example that we looked at previously in the course of sea otters. Sea otters keep the population of sea urchins under control, which allows the kelp forest to flourish and provides an ecosystem for all those organisms that need it. When you pull the keystone out, the entire ecosystem structure crumbles. So what happens when vultures are removed from an ecosystem? Vultures serve as a detritivore, or species that consume dead or rotting organic matter. When vultures drop out of an ecosystem, who fills that void? Carcasses of dead livestock and wildlife are left out in the open, and in India, this led to a massive explosion in the feral dog population. More feral dogs directly translated to a skyrocketing number of dog bites, which caused a devastating surge in human rabies cases, leading to increased human mortality and millions of dollars in healthcare costs. This is a stark reminder that ecosystem health is human health. While we're discussing rabies, please remember to never touch a wild animal with your bare hands if you can avoid it. Bats can be found at Texas A&M's campus, and so please, if you find one, notify the proper authorities and do not try to deal with it yourself. While you might not be as concerned about rabies because you very well likely have easy access to the rabies vaccine, let's think about our case study, which is happening in the old world of India, Afghanistan, and Pakistan. In these areas, in rural places there, it can be hours or even days of travel to get to the nearest health clinic, and it's not guaranteed that that vaccine is going to be available. Also, it's multiple shots that you need to take over and over again. So without treatment, it's also important to know that rabies is 100% fatal. Now we will begin applying the scientific method to solve this environmental mystery. First, we should consider our observations. You learned about these when you read handout number 1. Next, you consider what your question is. And lastly, at this stage, I'd like you to write your hypothesis for what's vexing the vultures. We are now at our first interactive break. Please pause this video and use the prompt on your screen to submit your initial observations, questions, and hypothesis for what might be causing the sudden massive decline of vultures. Once you've submitted your thoughts, resume the video. There's a possibility that you also might have a prompt within a different learning system of where to put your responses. So please follow the instructions provided. Welcome back. Let's add some more data to our puzzle. Field biologists eventually began recovering physical bodies of dead vultures. There were no bullet holes in the bodies, and the bodies were not emaciated, which means they were not starved. They did not starve to death. Consider these new observations. Do you need to change your hypothesis? If so, don't be concerned. The scientific method is rarely practiced in a linear fashion in real experiments. It's not uncommon to discover new information or new methods during the process, which require scientists to adjust their ideas or their approach to solving the problem. It's now time for our second interactive break. Please pause the video here, refine your hypothesis based off of new evidence, write out a prediction, and briefly outline a very rough experiment testing a plan that would prove or disprove your idea. Resume this when you're ready to see the actual data. Welcome back. Let's look at what scientists actually discovered. Featured here is a table from a seminal study testing different non-steroidal anti-inflammatory drugs, or NSAIDs, on vultures. While NSAIDs may sound new to you, they probably are not. A common NSAID used or prescribed to humans is ibuprofen. This class of medications, NSAIDs, helps to reduce inflammation in a body and the pain associated with that inflammation. Other things you might not be familiar with on this table are gavage. This is essentially force feeding a test animal. I'm sorry to share that with you, but it's just one method that is used in ecotox studies. On this table, I want to draw your attention to the NSAID, diclofenac, and meloxicam. In the second column, review the number dosed, the N dosed, N died, and percent mortality columns to compare the NSAIDs of vultures. For this study, status, source, and species of vultures were not significant factors. If you need the long description of this image, please see the notes in the slide for the PowerPoint. Please pause the video here and look closely at the columns for N dosed, N died, percent mortality, and answer the questions in the platform provided of what conclusions can you draw from this data. Before we look at more data for the vulture studies, let's establish a baseline framework for how scientists measure toxicity. In ecotoxicology or ecotox, or ecotoxicology, or environmental toxicology, we use a method called the dose response analysis to quantify exactly how toxic a substance is. In this method measures the strength of a toxicant's effects, or simply the number of individuals affected at various exposure levels. When conducting these tests, the dose is the precise amount of the chemical or toxin or toxicant the animal or test subjects receives, and we plot this on the horizontal x-axis. The response is the type or magnitude of the response or effect that we see, and this is plotted on the vertical axis. When you graph these two variables against each other, you get a dose-response curve. Typically, nothing happens until you hit a certain threshold, in some cases. But as the dose increases past a threshold point, the negative effects begin to climb. The most critical metric we look at in this curve is the LD50, or the lethal dose 50. This is the amount of toxicant it will take to kill 50% of the test subjects. Keep this framework in mind as we pivot back to our vultures and look at the specific dose response curve from one of the vulture studies. As you saw from the table, diclofenac is toxic, incredibly toxic, killing a massive percentage of the vultures tested, while meloxicam proved to be non-toxic to vultures. Take a look at this graph, the graph on this slide, focusing on the thick curved line. The x-axis shows the dose of diclofenac administered in milligrams per kilogram of body weight, and the y-axis shows the proportion of vultures killed. If you need the long description for this image, please see the notes for this slide in the PowerPoint. Pause this video one last time and analyze the dose response curve. What is the approximate LD50 for diclofenac in vultures? Submit your answer in the platform provided by the instructor. Excellent work. We've uncovered the mystery. The vultures were being acutely poisoned by diclofenac. Diclofenac is a common pain reliever, or was a common pain reliever and anti-inflammatory drug used in the 1990s by farmers in India, Afghanistan, and Pakistan. They used it because it was cheap to use for mass livestock, and they used it to treat arthritis in their cattle. When a cow died that had been treated with diclofenac, the culture there was to leave the cow in the fields and to let the carcasses be taken care of by the vultures. The vultures ate the meat of that carcass, ingested the drug, and suffered rapid kidney failure and died. I'm happy to report that there's been strong recovery of the vulture populations after diclofenac was banned in South Asia in around 2006 to 2010. But you might be asking, I don't live in India, Afghanistan, or Pakistan. Why does this matter to me? It matters because pharmaceuticals are a major source of hidden global environmental pollution right here at home. Think about it. When you take a prescription pill or an over-the-counter over-the-counter medication, your body doesn't absorb 100% of it. It doesn't necessarily metabolize 100% of it. A significant portion of that medication is excreted directly into your toilet, unchanged, meaning it's still an active medication. Furthermore, people frequently dispose of unused medications by flushing them down the drain. Here's the catch. Our modern wastewater system Our modern wastewater treatment plants were not designed to filter out medications and pharmaceuticals. They were designed to filter out solids and bacteria. And they are very, very good at that. Just let's put that there. We have a very good wastewater treatment system in the US. So once all those wastes and bacteria are filtered out and processed, and you have relatively clean sewage, that is then released back into the local rivers and streams, and then it will be taken back up again and taken through a drinking water treatment plant. So all that said, I do want to point out that our water supply is safe. It's safe from pharmaceuticals. It's safe for human consumption. This is not to alarm anyone on that. After decades of research, there is little to no evidence that exposure to pharmaceuticals traces in water negatively impacts humans. That's not what we're talking about here. That's not a thing. They've been looking at it for a very long time. But what we do find is that aquatic life is being impacted. Aquatic life and other non-human organisms. Because modern wastewater treatment facilities were never designed to remove pharmaceuticals, our natural waterways are constantly exposed to low level and low doses of human medications. Again, this is not a concern and has not been shown to have a problem for humans, but it has a profound effect on wildlife because they are constantly being exposed to very low doses, and it's all over them and all the time. So I provide two examples here. On the left is an image of the effect of exposing tadpoles to fluoxetine, which is called Prozac, and sertraline, also known as Zoloft. The tadpole on the right is representative of the treatment group that was exposed to a mix of these two drugs, and the tadpole on the left represents the control group that was not exposed. As you can see, exposing the developing tadpoles to both fluoxetine and sertraline has the effect of delaying metamorphosis. For reference, both tadpoles are exactly the same age. They are 57 days old. The image on the right of the slide shows the feminization of fathead minnows that have been exposed to the endocrine disruptor ethylene estradiol, which is the main medication in birth control pills. The fathead minnow is named for the fat patch that's on its head. You can see here, so this fat patch, the fathead minnow is named for this fat patch, which is visible in these normal males. So this little patch right here is a little bit more bumpy than the feminized male. So these are the normal control males that are numbered 57, 58, and 59. And you see that fish number 49 has lost its fat patch at the top of its head due to feminization caused by exposure to ethylene estradiol. In this way, synthetic estrogens from birth control pills act as an endocrine disruptor in waterways, actively feminizing male fish and disrupting aquatic reproductive cycles. The take-home message today is not that you should stop taking necessary medications. Please don't do that. Please take the necessary medications that you need and the ones that are prescribed to you. Modern medicine is vital. However, we must be incredibly mindful of our footprint. First of all, never flush medication down the toilet or the drain. Instead, utilize local pharmaceutical take-back programs or safe drop boxes. If those aren't available, you should dispose of your medication in undesirable materials like kitty litter and ground coffee grounds. The reason being is those are deterrents to animals that might root around in your trash, like raccoons. So second, also avoid buying medications in massive bulk quantities if they're going to expire before you can use them. Thank you for participating in today's case study, and make sure you submit your responses on the platform as instructed. Thanks, and gig 'em.